Right. Hello, everyone, and welcome to today's Beyond a PhD, hosted by the UK Metamaterials Network. Our guest speaker is James Watts, former advisory board member of the Centre of Metamaterials Research and Innovation at the University of Exeter, also former undergraduate students at Exeter, then doing his PhD at Exeter, and now working for Theta Technologies at the Science Park in Exeter. In between these stages, he had quite a few other opportunities he's going to talk to you about in a minute, giving you some insights and what he enjoyed about those various stages, and also some maybe tips and tricks what to consider as early career researchers and PhD students looking for job opportunities and to develop your career in the science area. I'm handing over to James. Enjoy the talk.
Thank you, Anya. So, before I start, if anybody wants to ask questions during my talk, please interrupt me. If you're online, please ask a question in the chat and Kellen will pass it on to me. So I've split the talk into several sections. There's a bit of background about me, what I've done basically after a PhD up to now, and a little bit about what I felt the differences between those companies were. And then I wanted to talk more about what the different types of employer are like and what the characteristics of those are and why that might be important. And then I wanted to talk about the recruitment process and how an engineering and science company goes about hiring staff and how you can make sure that you're right at the top of the list. And then last of all, I've popped in some tips and suggestions. Thank you, Anya, that's brilliant. So, as Anya said, I started off as an undergrad here in Exeter. I did a physics degree with electronics, but I was lucky enough to be sponsored by Plessey Radar on the Isle of Wight. So what that meant in practice was that I did vacation work and I got the experience in a whole host of the different departments in that company. So it's an engineering company. It designs and builds radar for air traffic control. And so I learned for the first time about RF and microwave engineering, and then how the hardware technology gets used to build up part of a radar system. But as well as that, I learned some of the processes and requirements that you have to manage in a industrial manufacturing company. And also I had the opportunity to go away on a installation site, but it just happened to be on a wet hill in Scotland instead of anywhere sunny. So having completed my degree here, I had the opportunity to stay here and do a PhD in Alan Usher's group in semiconductor physics, which is a fantastic experience and also really quite hard. And I have to say that I did my PhD, and it was only towards the end of my PhD that I was starting to think, what am I going to do next? And I admit I didn't put a huge amount of effort into looking before I started getting close to the end of my PhD. And I think my message now, and I'll probably say this once or twice during the presentation, is that it's a good idea to start soon. Thank you. Anyway, when I left the university, I was lucky enough to get the chance to work for the Defence Evaluation and Research Agency. Now, that doesn't exist anymore, but it was a division of the UK Ministry of Defence, and it's subsequently been split into Kinetic and the Defence Scientific and Technology Labs, DSTL, that some of you will be familiar with. So my job when I started there was as an antenna engineer. I designed the sensor at the pointy bit of guided missiles and did some really good had some really good opportunities to learn about how antennas work, what the practicalities of implementing them on a real system are. And at that point, I was working as a research scientist in a small team. Didn't really have any management responsibilities. I was just focused on individual projects that were funded by the UK Ministry of Defence and delivering the science and research along with those. And managed to generate some papers and a patent or two, and obviously some reports that weren't published. So whilst I was working at Defence Evaluation and Research Agency, I was early career. There's a big organisation. I think in total it was about 12,000 employees. I was on the Malvern site up in Worcestershire. And being a large organisation with that government service ethos, there was lots and lots of training and development opportunities available to me. So for example, when I needed to learn more about radar, I was able to make a case for some training, and I was sent away on a 2-week training course to Atlanta in Georgia. So I can't think of many companies where that would happen. So that's a really fantastic opportunity in that much larger organisation. So in 2001, DERA was privatised and it became Kinetic. And that coincided shortly afterwards with me moving out of a defence-focused team doing research on guided weapons and looking at how Kinetic and my team could take the research and the knowledge that was gained within the defence arena and apply it to real problems in commercial applications. And so I worked initially in a number of consultancy projects. So one of them was to use millimeter wave radar to detect cracks on railway lines. Coincided with a series of unfortunate accidents. And we showed that we could use a millimeter wave radar to detect cracks on the surface of the rail without actually having to touch them, which is quite good. And it did some other really interesting little projects on mobile phone detection in prisons and a scanning application, which probably can't talk too much about. I mean, at that point, I took on the management of a design team of around 3 or 4 engineers, and we worked together to achieve a decision about whether these technologies were viable in the commercial marketplace and what needed to happen next. And Kinetic, although it started out as DERA, was quite different. Certainly towards the end of my time at Kinetic, it really was transitioning to a more commercial basis, but really focusing on research and development. So a lot of that investment in people was still there, but the focus was much shorter term, much more about delivering a product or a solution for the next few years. Okay. So in 2005, I think it was, I moved out of Worcestershire and down to Cornwall, and I joined a company called Flam Microwave Limited. Totally different environment, really was a totally different environment. There's only 65 staff, and the company was founded 60 years ago or so by an engineer working then for Decca Radar. And its business was in the design and manufacture of antennas and waveguide components for radar, medical, satellite communications, and so on. And I think so working at Flam Microwave, initially as the chief engineer and then later as the CEO. Would you mind going back one, please? I was involved in a number of different projects. On the bottom left, that's a radar site up on a mountain in Scotland, providing air traffic control and defence coverage, and was involved in designing some of the waveguide that joins the antenna and the transmitter. On the right-hand side is a picture of a military vehicle. I don't know if you can see it, but there's two little boxes up near the radiator grille. And inside there is a system which I actually designed. And this was around the Afghanistan war. It was an urgent operational requirement from the UK Ministry of Defence. And I had a meeting with DSTL, I think, and there was a need. We worked out a plan, came up with a design really quickly, and went into production, and we produced many hundreds of these systems and made a difference. And that was amazingly satisfying, because I and my team worked together under quite a lot of time pressure to solve a problem, deliver it, and see it in service. And now when we drive around Salisbury and around military bases, we see British military vehicles with the little boxes on, and my children say to me, "Oh look, there's one of your things," and that's amazingly satisfying. And that happened because I was in a small, dynamic company that could respond really, really quickly. Okay. I was also involved in lots and lots of other projects. So the thing on the bottom left is a filter for a point-to-point radio communication system for mobile broadband. On the right is an image, a terahertz image of, funnily enough, one of my ex-colleagues from Kinetic. And you may or may not be able to see, but he's hiding a gun down by his leg underneath his trousers. This was produced with a terahertz imaging system, which some of the components were made by Flam Microwave. Again, really direct link between requirement, design, manufacture, solution. So that was absolutely fantastic. Okay, and then move on. So I left Flam Microwave in 2019, and I set up as an independent contractor, which is totally different. So what that meant was that I created my own private limited company, and using the services of an agency, I found a client that wanted some consultancy services, and I effectively worked to deliver a solution to them. So totally different from being employed. What it meant in practical terms was that at the beginning of the contract, I agreed a package of work that I would do, agreed what the outputs would be, and I agreed what the cost would be and the time commitments. And then I got on with it. And I had, the company that I worked with was a French company called Sequence Communications. They have a UK outfit, but also they're primarily based in Paris. And they are a chip designer and manufacturer. And they were needing to make a millimeter wave modem. So like your broadband modem, but using frequencies of around 30 gigahertz to get gigabit and higher radio connectivity using the 5G network. So the practicalities of working for myself to do this were really different to being employed. I had to work with the client on weekly or monthly meetings to talk about progress. And I had to define a plan, work through the plan, and make sure that I was actually going somewhere towards delivery, because although they were paying me as I went along the way, it was on the basis of delivering that end result. So practically, I wasn't paid a salary. I was paid as a director, so I could take the company's profits as my salary. So again, totally different working style. I was able to control when I worked, how I did the job, what tools I used, where I was, all those sorts of things. And as a running my own company, I could claim the expenses that I incurred running that company. I think now some of the rules have changed. There's a thing called IR35, which limits how the taxation can work for that involvement. But even so, if you can deliver a service to a company and they're willing to pay for it, then it can be a really effective way of working, where you, as the employee or as a contractor, control the work that you do and how you do it. The downside is it's quite risky, because you have to go out and find that work. And when you come towards the end of an assignment, will you get another one? Who will it be? Where will it be? What will it be? And how much will they be prepared to pay for the task that you are going to do for them? I think this is much easier later in your career, when you've got a network of contacts for people that you could talk about problems with, and they can ask you to contract for them. I think it's very, very difficult early on, but it does really highlight the need to establish that network of contacts much wider than your university, and just show interest in things so that you can see that you are of value. So that brings me to where I am now at Theta Technologies. So my role at Theta Technologies is as Chief Technical Officer. I've got the company's research and development company, and it's taking a unique acoustic non-destructive testing technique from research and development into delivery of product. And the technique is applicable to aerospace, defense, nuclear, automotive, medical. And our task is, in the next 6 months or so, to take the product that we've built and start to sell it to customers. So my entire career up to this point has been RF, microwave, radio, and now I'm working as the Chief Technical Officer and Director of an acoustics company. And I'll be honest, acoustics is not my field, it's not my area of expertise, but it doesn't matter. And the reason it doesn't matter is because they've got a team of good engineers. They understand the technology, they understand how it works, how it can be used. And as an outsider coming in with different perspective, I can bring in some ideas from radar and RF, but I can also ask the stupid questions. The great thing about being a physicist is that ability to stand back, know enough about a subject to identify what some of the issues might be, and ask those stupid questions. And some of them aren't stupid, of course. Some of them end up leading to real advances. So again, it's another different type of company to the others that I've worked in. With 15 people, the company is backed by private investors, and they want to see a return on their money. And of course, if they don't see a return on their money, then the company has no future. And they might not see a return on their money because the technology could be risky. It works, we've proved it works. So that's hopefully that one sorted out. But getting to market and delivering product at sufficient level to make a profit, that's risky as well. Will there be sufficient customer demand? Can we persuade a market like aerospace, which is risk averse, that this new technique will work? Again, we're really confident that we can, but there is risk there. On the other side to that, there's some real opportunity. Being at the beginning of a commercialization of a company means that we've got something new, something that other people haven't got. And that means that some of the biggest companies in the world are prepared to talk to us. So I've had Teams or Zoom meetings with the chief engineer of Boeing, all the other companies you can think of, so Airbus, and go through a list of some of the largest organizations in aviation, aerospace, defense. We've spoken to a lot of them, and that's because we've got something that's novel. And then the other opportunity is that as an early participant in this company, I've got a share options package like all the other employees. So when the company's sold at a profit, I'll benefit personally, and maybe go on and do something with that. So again, some risks, but also some opportunities. So standing back and thinking about the types of employers that I've worked for over the years and how different they are, it strikes me that actually choosing an employer is a multi-axis problem. There's a whole range of things that are important to me as an employee, and by extension you, and different sorts of employers are in different places on each of those axes. So if we look at job security, a big civil service or commercial defense company like Kinetic or DERA are very secure. Things will change, but they'll change relatively slowly. They have long-term projects, and a good person in one of those organizations can expect to work for there really as long as they want to. The downside often is that those relatively lower risk organizations pay lower salaries. And you can do better if you go to a smaller company, a company that is growing rapidly and is closer to the customer. And so if you are able to influence the success of a company more, ultimately you get paid for your value to the company. If you can show the company that if they employ you, then your skills, your experience will help them to make a big difference to their own success, you can command a salary for that. Moving further around on one of the other axes, career progression. If you look at a smaller company like, for example, Flam Microwave, which was a family company with 60 staff, I was very lucky because I joined as the chief technical officer, as a chief engineer, and a few years later, I had the opportunity to be promoted to chief executive. But actually, if that hadn't happened, there were no other alternatives. So in a smaller organization, your route to career progression is to go and join another organization. So that might be an issue, or it might not be. And I think early in your career, it's quite easy. It's easier to be in a large organization where there are more opportunities to move around, especially as you don't really know exactly what your niche is. Timescales, sorry. Oh no. Okay. Timescales is a different axis. If I go and join an organization that is dedicated to designing, building and delivering an aircraft carrier, I might have a whole career between defining the requirements and delivering the aircraft carrier. So I'm unlikely to have the satisfaction of seeing the whole project from beginning to end. Whereas in a smaller company, such as the example I gave you for at Flam Microwave on delivering that military system, that was a few months. And there's lots of satisfaction to be had from seeing something as a requirement delivered. But the flip side to that is that in some companies, in some environments, that comes with a lot of stress. So that it's just, there are balances. And that moves on to working environment. In a smaller company, you tend to have a very much smaller team. It's great that you've got access to experts. You might be sat at a desk next to the world expert in a discipline. And if you're in a bigger organization, they'd be in an office buildings away from you. But they tend not to have access to the staff canteen, the gym, and some of the training opportunities, the networking opportunities. So the working environment's different. The satisfaction, making a difference thing, I think that and timescales are really quite linked. And the last axis, I think, is the opportunity for personal, professional development. In a bigger organization or in an organization that's part of a group, you have the opportunity to come out of your job and work a bit with some of your peers to learn a bit about what they do and broaden your experience. Whereas in a smaller organization, it's much easier to stay narrow. Okay, now you can. So the last bit, I wanted to talk about how an engineering or science company goes ahead and recruits research and technical staff. So there's a bit of job adverts in the magazines and newspapers and using recruitment agencies, but these days, social media, personal contacts are absolutely vital. So LinkedIn is, if somebody's recruiting, the first thing they're going to do is share an image saying, we're recruiting, and that's basically free. And it means that they communicate to their network, which is probably in the right discipline, that they're looking for good people and they're asking for recommendations. So that's your first opportunity. Use social media to help you. Work with the academics and industrial contacts that you've got access to help you. So if one of your industrial contacts is aware that you're really excited about a particular field because you've had good conversations with them about your potential future career, then when they see that opportunity, it'll come your way. If you don't have that conversation, they'll see it and move on. Flip side to that is that don't forget to check your own social media profile, because one of the first things that I do when I consider an employee for shortlisting is go and look them up online. I don't try anything creepy, I don't go too far in, but if when I type your name and something that identifies where you are, I come up with a social media profile that tells me something about your personality that I don't want to know, or that is the opposite of my company's values, that's the end of the conversation. It won't go any further. So bearing in mind that things live on the internet forever, start checking your social media profile now with a view to it being looked at by employers. You can lock it. You can lock all the bad stuff away, but anyway. So talking about the recruitment process, an employer going on to recruit somebody for a research or science role, looking at somebody who's coming out of a PhD, has got some obvious stereotypes in their mind. They think that you are a really intelligent person who's achieved because your background tells them that. But they've got some horrible stereotypes sat in their mind that you've got to break. So you've got all this amazing knowledge and experience. Can you apply it to what I want you to do? Have you got practical understanding so that you can do more beyond the narrow piece of research that you've been doing for the last 3 or 4 years and apply it to my problem? Because fundamentally, if I'm employing you because I want you to work on a problem and solve it. So it won't be exactly what you did in your research, unless you're very, very lucky. You need to be able to transfer that skill and experience and transfer it to my technical area. you're not going to be working on your own anymore. And I know that PhD has an element of collaboration, but it's primarily a personal endeavor. But in any realistic employer, this is a team activity. So I need to see that you are cooperative, want to listen to new ideas, and that you're going to fit in to my team. And that's both people who are academic and at your level, but also the administrative staff, the managerial staff who possibly haven't come from an academic background, but are really good at organizing things, and the machine shop technician who get it right, they can make your life really, really easy. Get it wrong, the opposite. And then the last one is delivery. Can they take their knowledge and experience and deliver the research in the right time without overspending massively? And can they do that by following a plan? Lastly, in a smaller company, you might come in as a research engineer or scientist and focusing on doing some really good research, but there'll also be some tasks that you need to do that aren't that exciting, but they need to be done. And in a smaller organization, people have to work together to get the whole job done. So when I'm assessing an applicant, is this applicant somebody who's going to join in and get their hands dirty and do the tasks that aren't that exciting just because they need to be done, alongside all the really good research? And I want to see this with evidence. I don't want someone to come and say, yes, I can do this, yes, I can do this, yes, I can do this. I want them to say, you can see that I can do this because I've done it here, or I've done this piece of work experience or voluntary work, or I did this as a subset of my PhD. So evidence is absolutely essential. So the process of recruiting in a modern company is the company decides what they want. They define a job application, a job description, and then they seek applications. And they'll do that via lots of different routes. But ultimately, they'll get a load of applications come in, and then they will select based on those applications. And the selection process is basically, I've asked for a set of skills. Does that application show me that the person who's applying has got those skills? And do they look like they're even interested? And I can tell you now, if you put in an application to a job that describes what you've done, describes who you are, and then goes through the requirements that the employer's advertised and demonstrates with evidence that you can do that, that is you, that the person that they're asking for is you. If you send an application in that's got those things in, you will be in the extreme minority, because the general standard of applications that I've ever seen in any of the companies I've worked in isn't great. There's been some notable exceptions, but in general, the standard of applicants or applications isn't great, which is a real shame, because there are good people out there who undersell themselves because they think it's a bit embarrassing. Doing a sales and marketing job on themselves is all a bit uncomfortable, but it's absolutely essential. Because if you tell the employer that you are the person that they're looking for and back it up with evidence, then you've made their life easier. So you get shortlisted and then you get invited to interview. And in the interview, it's about proving that the things that you've said about your ability to satisfy the requirements of the job description are actually true. And you need to support that with evidence. That needs to be from your PhD, your undergrad degree, and also your wider experiences outside of university, whether that's in your personal life or through going out and getting work experience. The winning candidates will have all the academic and technical skills that have been asked for, but they'll also have all the other skills that sometimes are asked for and sometimes aren't. So their practical skills, the ability to plan and work together, to present their ideas and their results, and to be able to talk to people, talk to customers, talk to other stakeholders in a calm, clear, professional way. And actually, there's also a bit of an expectation that employees will understand the legislation around the work that they do, health and safety, and at least have an appreciation for it, even if not a detailed encyclopedic knowledge. And did I say examples? Examples are really, really important. So don't just say that you've done something, prove it. Thank you. So my last tips really are to treat the job hunting process in exactly the same way as you would do as a research activity. Use your scientific training. So you start off with a hypothesis. What sort of thing do I like doing? What kind of job would suit me? I've maybe come up with some ideas. At this stage, I don't know is an unacceptable stop. So come up with a hypothesis, whatever it is. Do a literature review, look online, use every other technique you can think of to see whether you think that hypothesis is possible. Would I like doing that? What does that role actually look like? Who are the organizations that are interested in that sort of thing? What sort of candidates are they looking for? Would I fit into that sort of organization, both technically, but also personally? If you really hate the cold and the only opportunities for your chosen role are in the Antarctic, might not be suitable. And then looking at the literature review, including adverts for jobs that don't exist anymore. What skills are they asking for? Have I got them? What do I need to do about it? Then you move on to the experiment section of the process. So you've got to test that hypothesis. So if you don't know what you want to do, then make a guess and go and test it. Seek out some work experience. Talk to some people that work in the organizations that you're kind of interested in. See whether what they do day to day is interesting, whether it's the sort of thing that you could see yourself doing, and whether there's actually openings for people like you. And you can do that either by meeting at company events, trade shows, conferences, or just by ringing up and talking to somebody, or using the contacts within your department or their industrial contacts to reach out. And use LinkedIn, use social media to look out for posts in an area that you're interested in, see who's posting, say, that looks really interesting, can I come and talk to you about it? Because you'll be surprised how often people say yes, because people are interested in their work. And then get your application in, make it match the job application, or the job application the job description you think would be there if it was advertised, if it's a speculative application. And then review. Were you right? Is this actually something that you want to be doing? Were you effective? And if you weren't effective, what do you need to change and go back to the start? And I think if you start that and you go through that process, then you build a more and more accurate picture of what it is that you want to do, how you're going to get it, and you make it happen. And where you see that there are gaps that are preventing you from being successful, you've got an opportunity to fix them. Okay. So my last comment is do it now. Even if you're in year one of a PhD or at the start of a postdoc, think about where you're going now, because if you've got an idea of where you want to get to, then you can look at whether you've got the ability to get there, and if you haven't, you can do something about it. If you don't do that, as Lewis Carroll didn't say, if you don't know where you're going, any road will take you there. So if you don't plan your next step won't be the step that you really deserve. And that's pretty much it for me. So if there's any questions, I'm happy to take them. But if there aren't, or even if there are, reach out to any contact that you've got that can help you to find out more about the workplace and establish whether you are suited to doing a job in a particular role.
Lovely, thank you very much.
Okay.
Brilliant, thank you. It is really interesting what you just said about make it bespoke, bring examples, and really look at the job advertisement. From my experience, we just had to post advertised, and we had to re-advertise. Like basically, we had applicants sending in applications that didn't address a single point of the person specification. So really, when you look at a job advert, take that serious. So if they're asking in the job specification for your knowledge and your experience, it's usually saying things like ability to solve problems, or a track record in working in a certain environment, or being able to lead a team, or being a team member. Addressing these individual points, really taking them on board in the application and bringing examples of, yes, I've done that like this in that environment. I hosted as a PhD student movie nights, for example, or I submitted, we just had a call out for summer studentships in the network where we encouraged the ECRs and PhD students to submit proposals. That is huge to be able to say in an application, I have actively sought out funding, and I've supervised a summer student, I have leadership experience, and really thinking about all the stuff people have done, or you have done during your PhD within the project, and in particular outside the project, and bring these examples across. It's like, I think from my perspective, that's the one reason why we had positions where we didn't appoint and re-advertised, because all the candidates sent a blurb, a generic text, you know, something, yeah, I can do this. Okay, how? They didn't think about the application and the individual specifics we asked for. Therefore, for me, it was like, well, if you don't even think about this now, if you don't answer the questions now, how are you going to do a good job? I don't trust that you will be able to do a good job. So I think that is really critical.
Yeah, I couldn't agree more. I think if an employer has bothered to write down something in a job description, and especially if they've advertised it, they've actually paid for those words to appear somewhere. So they kind of mean it. So if you respond to that text by ignoring it, it's not a great start to an employment relationship. So I really, really would encourage people to look at the job description or ask for one and address the elements of the job description explicitly. I was talking to Anya earlier about an example of a candidate that applied who was effectively a contact of somebody else that I knew. So I already knew that somebody else thought that they might be suitable, and the application was shocking, absolutely shocking. And so I responded to it by sending a copy of the job description in Word, which I put two paragraph spaces under each line, and I said, please can you send me this back with something written in every box, and I want evidence for each one. And it came back, to their credit, with all those boxes filled, and some really good examples of practical experiences that showed that they had that capability. And wow, actually they are the right person, and I did employ them, but I would have done on the application. So that's absolutely critical.
So I'm just thinking about the audience online and also the audience in the room. If you have any questions you'd like to ask, now is the opportunity to do so. Other than that, can they find you on LinkedIn as well?
Yeah.
James Watts?
Yeah, funny enough.
Yeah. Right, so maybe that's a starting point to build your network if you're not already operating on LinkedIn.
Yeah.
Just checking the chat. No questions by the looks of it. So now is the chance to unmute yourself and just stick your hand up if you want to. Other than that, I'll link you up with Greg in a second.
I have a question. We've obviously worked at several different size companies and scales. What was the motivation for moving between them? For one example. Say.
Okay, so when I left Kinetic, for example, Kinetic's a fantastic organization, was then, is now. But I left Kinetic because I felt that I wanted to see a product from start to finish. And as Kinetic started to become a commercial organization, I could see that the sorts of tasks that I was getting were the really introductory, can we apply our technology to this problem? And I was doing some really interesting projects, just getting them started. And when we got to the point that we said, actually, yes, this technology will work for this application, I had to hand over to somebody else. And so I moved to a company where I could actually start off with the requirements and see it through design, manufacture, delivery. When I left Flam Microwave, I left Flam Microwave because I felt that I'd done everything I could do there. And I wanted to try something new and bigger and work in a different organization.
So we've got a question in the chat from Rachel saying, what is the military box?
So the question is, what's the military box in the image of the armored vehicle? I think I'll have to let you look on Jane's defense and see if you can work it out for yourself, because I don't think I can tell you too much about it.
Fair enough. So
the first question on chat, and I can't answer it. Fantastic.
Oh well. Right. So I think at this stage we are going to close the session. Thank you ever so much for your time.
Okay.
It's hugely appreciated. We will put the talk up on LinkedIn, on YouTube at some point on the Metroteers Network channel, so for people to share and find you again if they like to. Other than that, thanks very much to the audience in the room for making the effort of being here in person. It's hugely appreciated. And also to the people online for taking time out of your day to listen to this. If you've got any other questions or suggestions on what you'd like to hear about in our Beyond the PhD talks, or for early career researchers in particular, please do send us a message to info@metamaterials.network. On that note, have a lovely weekend.
Thank you very much.